Etherchannel. Etherchannel. Very nice name. They've given a very good name for this concept. Etherchannel. There is also another name, equivalent name, that is also nice, meaningful. Port channel. What is this actually? It's nothing but aggregation of links. Aggregation of multiple links, you can say, or multiple ports, you can say. Because you aggregate ports, we call it as port channel. What is connected to the port? Ethernet wires. So it is also called as ether channel. So what we do is we aggregate them, we combine them, we bundle them. For example, I have access layer switches connected to this switch. There are 5 switches connected to this one single switch. This is a big switch. There are a lot of switches connected to this big switch. Likewise, I have another switch connected the same way. I'll call this a switch 2. So switch 2 and switch 1, they are not just one switch traffic, they are having traffic from various switches. The small switch 1, 2, 3, 4, 5, all the traffics, each switch may have some 24 computers connected, 24 PCs, 24 PCs, 24 PCs, So you can see now approximately 100 computers traffic, 100 computers are connected to these 5 switches, and their traffics are coming to one single switch here. We call this as distribution layer, sorry, this is access layer. From the access layer it is coming to distribution layer. So in distribution layer you have 2 switches for redundancy. These 5 switches are connected to the left hand side switch and the right hand side switches for redundancy. If one switch goes down, still you have path via the other switch. Loop is prevented by STP. So now if you see the traffic that is coming out from this switch, will be really high, very high. Let me repeat again. This small switches in red color, because of STP loop, they may be connected, they may not be having all this link active. See, the traffic that goes like this may come back. Okay, let's say if there is a link here, may come back like this and form loop. To prevent this, STP is going to block one of the link. So what I'm saying is, one of the switch will be standby and the other is going to be active. For all the traffic that is coming from the 200 PC, only one is going to be active, other is going to be standby, because there is a link between the switches as well. To prevent loop, now STP is going to block one of the ports, or even if there is no green link, there are chances for you to form loop no, this way it cannot happen. Will it happen like this? Yeah, why not? It is possible. It is possible. So there are chances for loop to occur. So STP is going to block one of the link, and one switch will be always standby, the other is going to be active. So you are seeing that 200 computers traffics are going out to this core switch, the green switch core, to this core switch. It's going to the core switch. Now think, if each PCs are using 100 meg capacity, so you got 200 into 100 meg, which is 20,000 meg. 20,000 meg is equal to what? How many GB? 20 GB throughput. But this link capacity is only 1 GB. Only 1 GB. I have redundant links, but STP is going to block all this. Why? Loop will occur. So to prevent loop, STP is going to block. Now 20 GB of traffic using 1 GB, very poor design. There will be too much of delay in this link, congestion. You agree that point? Now, how do you prevent this? What we do is, we try to bundle this as one single logical link so that STP will not block it. When it is separate link, STP, to prevent loop, it is going to block 3 of the link port. But when you aggregate it, it will look like a core switch connected to a big pipe, one big thick interface to switch 1. So that's the feeling that you get, the switch gets. So aggregation is good. You prevent unnecessary block of port because of STP. We don't waste our bandwidth, we don't waste our link. See, you have 4 gig link, but only 1 gig is in use because the other 3 are blocked. This is blocked, this is blocked, this is blocked. So you are wasting 3 GB of resource that you have. But when I bundle, I get 4 full GB, 4 GB of bandwidth. How many I can bundle like this? I can bundle up to 8 links. You can have up to 8 active links. So you can have 8 GB throughput. You see? So you have now improved bandwidth, more bandwidth. Even the STP cost will be lower as you increase the bandwidth. The default STP cost, for 100 meg it is 19. When you have 500 meg, the cost is going to be reduced like something like 7. So aggregation is good. Question please. Switch 1 to, it depends, என்ன device, it depends on what device we use. It depends on what we see. Some devices they got 10 gig ports, like ASA firewall, ASR routers, but in general most of the devices comes with 100 meg wire, most of the LAN switches, and some switches comes even with 1 gig port. So but I have seen mostly people have 100 meg or 1 gig. There are special devices like a Nexus and ASR that supports 10 gig. Nowadays even our Nexus supports 40 gig. We also have 40 gig port. One port is 40 gig. So if you have 4 ports, then when you bundle 4 into 40, then you will get 160 GB throughput. So why not? You go under the interface and you will see the speed there, bandwidth there. I'll show you later. So mostly, if it is fast Ethernet, if they write FA, it is not mostly, always it is 100 meg. Whether you check or not, it is going to be 100. If it is Ethernet, it is 10 meg. Ethernet wires are 10 meg. If it is G, it is 1 gig. There is also TG, 10 gig. So name itself will tell you. But in Nexus, we don't have all these variations. We simply call it as E, even though it is gig, we call it as E. We have a common name to call in Nexus. Yeah. So I'll show you how to check it later. So we got multiple links between the core and the aggregation switch or the distribution switch. We need more throughput so that too much of oversubscription can be avoided. For that we need this concept called Etherchannel or the port channel. So port channel is nothing but the aggregation of links, aggregation of ports. So you bundle multiple ports on both the side, you bundle them so that it will appear like one single logical link. They are not subjected to spanning tree protocol. They are not subjected to spanning tree protocol. So all the links will be active and you will have very good load balancing. If one of the link in the bundle goes down, no worries, the other links will take the traffic, so there is no downtime. Whereas if you don't have this Etherchannel, spanning tree will block to make unblock. It takes some time, there will be a lot of packet drop. Etherchannel saves time. Etherchannel provides redundancy. Etherchannel provides load balancing, high availability. It reduces oversubscription. So Etherchannel is good. The basic requirement to have Etherchannel is you need to bundle only similar links. So bundling of link is very important. Now what I was telling is, when you try bundling links, they need to be of similar links, meaning all 4 links that you are trying to bundle should be access or trunk. You cannot mix one access link and then one trunk link together. No, they both need to be a trunk or they can be access. It can be trunk bundled or access bundled. Yeah. But what you cannot bundle is auto, means dynamic auto. You know, right? By default all switch interface will be in dynamic auto. They can form trunk at any moment. So you cannot leave it as dynamic mode and try forming either channel. It need to be either axis nor or trunk. So only a similar link can be bundled, and all the links should be of same bandwidth. Don't try to mix 1 gig link with 100 meg wire. I cannot bundle 100 meg wire with 1 gig wire. It cannot be done. So when you say similar bandwidth, it means, when you say similar link, it means bandwidth, type, axis or trunk, and so on. So it should be similar link, similar bandwidth, similar speed, similar duplex. Only then you should bundle. The other one is, none of this port should be a span port. What is span port? You cannot use this one single port. This blue color. If this link is a span link, that cannot be a member of a bundle. So what is span? Switch port analyzer. What it is? Any traffic that is coming to this port will be copied to another port also. When a traffic is coming to this port, a copy will be made to another port for auditing purpose. So if you are going to use one of the port as a span port, no, you cannot put that port in bundle. It should be separate. A span port cannot be a member of a bundle. But you can span the entire ether channel, but you cannot have one single span port as a member of the bundle. Cannot be. Right? So now this ether channel aggregation of link is done in 3 ways. One, between the two switch, you go and turn on this bundle manually. On mode, we call it as on mode. Both the side you go and enable this ether channel, and the ether channel comes up. There is another way. You enable either LACP protocol, which is an industry standard protocol, or PAGP protocol. Either you enable LACP or PAGP to bring the ether channel up. So first method is on mode, second method is LACP, third method is PAGP. On mode is not recommended. You can use LACP, which is widely in use. PAGP is also used, but only in a Cisco environment, because PAGP is Cisco's. When I have a Cisco or a switch and another Cisco switch, I can have any of these three. I can have any one of these three. But when I have a Cisco switch and a non-Cisco switch, the only option left is LACP. If you are using a negotiation protocol, LACP you need to use. Otherwise you need to enable manually on. But LACP is recommended than you manually turning it on. If you are going for protocol, and when you have a non-Cisco switch, with Cisco switch or without Cisco switch, LACP. If you have both the switches with Cisco, then you can go with PAGP. So on is just going and saying on both side on. LACP has got two modes. One is active and passive. The other one. PAGP has got two modes. Same like active, we have something called dynamic. Same like passive, we have something called auto. So LACP, as I told you, it is industry standard. LACP stands for Link Aggregation Control Protocol. PAGP stands for Port Aggregation Protocol. Port Aggregation Protocol. AG stands for aggregation. Port Aggregation Protocol. Here L stands for link, A stands for aggregation, C control, P protocol. Now you can say active here, which means you are enabling LACP, and the other side can be passive or active, but one side must be active. Both the side active is good. Both will try negotiating and form Etherchannel, but one side active, one side passive means active will go and initiate and passive will form. Passive will not initiate. Passive will wait for someone to initiate the Etherchannel. So active side will initiate. When you say active on both sides, both will initiate and try forming Etherchannel. Now one side auto, another side dynamic is good, which means you are using PAGP, Cisco Proprietary Protocol. Both the side dynamic is also good, but at least one side it should be dynamic. The other side can be auto or dynamic.